This video is a story about getting out of my own way, a story about actually finishing projects that I've started, a story about overambition, about mistakes and failures, a story about celebrating the finish line, even if it's not the way I wanted. This video is a project video. It's the top of the funnel, the entrance to the rabbit hole, which I've been gazing at for a few years now, walking up to the edge of just before backing away. This video is the first of what will hopefully be many more maker videos, workshop videos, me hopefully inspiring you to get out and make something for yourself, or at least make something of your own. This video was a hard one. This project itself challenged me in many ways, expected and not, and revealed that the tools that I had relied on for maker projects up until this point may not be viable in the long term. This video is sponsored by ARM. ARM designs the CPUs that lie at the heart of the Raspberry Pi I use for this build, in the keyboard that I used in this build and wrote the video script for this video on, and even in my 3D printer that I used to print all of the parts for this build. ARM technology powers the tech all around us and touches 100% of the connected global population. We'll touch on them more in a bit and in the link in the video description.
I've always been fascinated by cyberdecks, portable computers that could be worn, built into a bag, or carried around to quickly allow its user to tap into cyberspace and surf, hack, or manipulate the world around them. While an interesting and unique concept in fiction, the idea became obsolete when we got these rectangles we carry with us everywhere.
Smartphones are great, capable of more power than any computer I had growing up when I was really falling in love with the cyberdeck concept, but I don't feel like I own it. I didn't make it, build it, contribute to it in any way. These days we're allowed so little customization and control over our tech. It feels like we went in a completely different direction than what the future looked like in the 90s and early 2000s. Plus, it's distraction city. If I just wanted to plug a keyboard into my phone and write, I'll have to fight notifications, calls, and fall into the pitfall of just browsing for what I want to do before I get to it. This is why I, like many others in my age range, have started practicing digital minimalism. I highly recommend Cal Newport's book on the subject and maybe Johan Hari's Stolen Focus as well, but the gist is not trying to use as little tech as possible, but instead to truly evaluate if any given piece of tech, service, app, etc. will have a meaningful, positive impact on your life, and if that tool is the best tool for the job, for its given purpose. This has led me back to single-purpose devices. It's great that our computers and phones can do everything under the sun now, but that doesn't make them the best tool for every job. There's always sacrifices.
For photography, I shoot on real cameras, a beefy mirrorless for digital, with an ARM processor in it by the way, or a small film camera that goes with me everywhere. That camera has no processor in it. No distractions, subscriptions, privacy concerns, just me and my photography. For music, I've gone back to vinyl and CDs and my iPod for intentional listening, restricting streaming music just for radio like background play or discovery, and not paying an extra subscription for it. For writing, I've been trying to figure out the best possible solution. Electronic word processor, iPad and keyboard, typewriter, handwriting?
Do end up journaling and writing initial scripts by hand, but for things that I need to take long form and end up in digital in the long run anyway, I gotta type it. The iPad had been my most immersive writing device thus far, but it's all app-based, not file-based, and the chiclet keyboard isn't amazing for lengthy writing sessions. Along the way, as I was trying to figure this all out, I fell in love with the Keychron K3 wireless, ultra-slim keyboard. Low profile, keycaps, brown switches, zero hand fatigue. I have one at my main desk, and I bought a second one for this project.
It was time to build my own writing device based around this keyboard. A writerdeck.
Originally, I had massive plans for my first cyberdeck. A big primary display, secondary screen panels for additional information, a completely custom chassis, this beefy Quartz 64 computer with NVMe storage, front and rear cameras for vlogging or video notes wherever I happen to be writing at, and I was going to extract the status screen from this huge battery bank, so I always had battery status in front of me. I got overambitious. The parts sat in a box for 2 years, with me occasionally pulling them out to play with or make more plans. The screen, or more likely the ribbon cables for it, died along the way. It was just too much to take on for a first swing at such a product. ADHD go burr. I do this all too often. I buy up a ton of parts for a new hobby that's definitely, absolutely going to become my new lifestyle, and not just a fleeting fixation phase that will fly away in a matter of weeks. I promise. And by the time the parts arrive, I lose momentum and they sit on a shelf, begging me to spark the interest again.
This time, the interest did come back, but I knew I had to dial back the scope. I wanted to build a simple self-enclosed machine for me to write on, and only write on, using this slim keyboard. For the screen, I went with this Waveshare 11.9-inch ultra-wide mini display that I had picked up for using as a chat monitor for a while. The driver board is attached to the back and it takes standard HDMI in, uses micro USB for power. For the computer, I went with a Raspberry Pi 3B. I have a couple of them lying around. I don't need the latest model just for word processing, so why not?
It's honestly incredible that we have Raspberry Pis and other similar single-board computers at all. These credit card-sized computers can be a traditional desktop computer, or be equipped to act as your firewall, a video streamer, a whole webcam, or even be used for AI projects. This is all thanks to the power of this little square right here. This has an ARM processor embedded in it, as do most maker SBCs of this style. ARM designs portable, energy-efficient, powerful CPUs that are in devices all around us. Like I mentioned before, in this project alone, there's ARM-powered chips in the computer, Raspberry Pi, in the keyboard, the Keychron K3, in my 3D printer, the Bambu Labs A1 that I printed all these parts on. They're in my music gear, my TV monitor, my smartphones, cars, and servers used in most tech services that you rely on every day. To learn more about how ARM powers the future, check the link in the video description.
My original design goal was to make something that was small, a joy to write on, and could be portable, ideally baggable, and go with me anywhere, while still having a big enough keyboard to not hurt my hands or slow my writing. Bad keyboards break a writing experience.
I wanted to design a chassis for the screen that would allow me to house the Pi. Now, I could have probably saved a lot of headache and time by just mounting the Pi to the back of the screen. It has the mount points already and even came with these dongles to quickly join the power and HDMI ports together. Why didn't I do this? I just like making things difficult for myself, I guess.
The first step was to start taking measurements and planning basic shapes. I needed a rectangle that could house the entire screen and a cutout for the Pi's motherboard. I got my measurements, did some basic sketches, and sat down to 3D model.
Well, I'm usually a pretty smart person. I had an easy time in school. Undiagnosed ADHD was a struggle, but I always performed well. I keep dropping my remote. I always performed well for the most part. I was teaching my tech teachers how to use computers as they rapidly changed in grade school. I was building my own PCs by middle school, and I'd go on to make this whole career for myself of teaching technology on YouTube. I quickly intuit most software and can learn streaming, video production, some programming tools quite quickly. But 3D absolutely wrecks my brain. Even away from technology, trying to think of in terms of three-dimensional space just doesn't compute. I've got bad depth perception. I can't tell if things I hang on the wall are straight, and trying to guess where things should be in the third axis just blue screens my noggin. So I've used Tinkercad for my 3D designs thus far. It's worked well for me up to this point, and I've been quite pleased at how quickly I was able to pick it up once I really sat down with it compared to my years of trying to do the donut tutorial for Blender over and over. I've made lots of projects and designs in Tinkercad, but it's a tinkering tool. It's not really designed for serious precision work, and it was absolutely not the right tool for this project. After I put a couple hours into designing my first basic shapes, I failed to find a usable Raspberry Pi 3B model to import into Tinkercad for reference, and instead relied on an imported model of a case for a Pi to embed in my project. I realized at this point that I would need more precise tools for the design process. I had every intention of grinding my way through learning Fusion 360 to finish this project and do what I needed to do. But the imported model of the Pi case seemingly made it impossible for Tinkercad to export my project to Fusion, and I really didn't want to have to start over from scratch. So I never ended up changing programs. This was a mistake, but it's easy to fall into sunk cost fallacy when you've already been ankle deep into a project and behind on deadlines. I fired off my first prototype part, just a half of the chassis to slide over the screen. It printed perfectly and resulted in a very non-functional part. The slot for the screen was a touch too small, as was the mount for the Pi, and I didn't even make any sort of cutout for you to actually be able to see the screen at all. But that didn't matter. Being able to rapidly prototype my ideas like this and quickly get a physical object in my hands is immensely gratifying. Making your own stuff, making something physical in the real world, is one of the most rewarding tasks you can take on. Whether it's art, crafts, gardening, printing your photos, or building stuff, please do yourself a favor and make time for it before it's too late. It can really enrich your life.
The first print reassured me that my general idea was going to work, and so I got back to designing. I tweaked sizings, added a cutout for the screen, made a slot and notch for me to glue the two halves together, and started making cutouts for the ports on the Raspberry Pi and the screen, adding posts for an eventual hinge. I just had to make a hole in the Pi mount to allow room for a heatsink on the backside chip, just to be safe. I started adding holes for me to mount the Pi into the case somehow. Along the way, I picked out a cooler for the Pi just to keep it nice and cool and protected. I actually picked out two. The first one I picked out seemed perfect in terms of a slim profile, but it wouldn't end up working at all due to the way that it mounts. But the second one had a silent fan, RGB lighting, and a tiny OLED screen for system information. This looks amazing and wouldn't require me to change my idea at all. I also needed a power solution. I didn't want to use this giant Anker power bank I originally reserved for this project, so I grabbed this MakerHawk UPS and battery hat for the Pi. It takes two 18650 batteries, which I have a good supply of, and has power for the Pi and screen. I then had to make cutouts on the other side of the chassis to mount this into.
It was going well. I was absolutely in love with my vision for this thing, but I kept running into little issues. Getting spacing and sizings exactly right is a nightmare in Tinkercad, especially for things like the mounting holes, where I need precise measurements, not just of the general shapes themselves, but of distances between them and walls and other objects and those little things that you could measure out by hand, but in Tinkercad, there's not really anything for. Plus, I ran into this weird thing where the notches I made to glue the halves together, I mirrored one half to make the other half, and somehow these never lined up. Don't know how that happened, but Tinkercad is just not cut out for this, and I should be really using more professional tools by now. Or I'm just making that many beginner mistakes that I don't know what I don't know, and maybe I have no business moving on to more professional tools. I don't really know. As a result, I blew through about 7 prototype prints for this project before reaching a final draft. While my Bambu Lab A1 printer is super fast, as I covered in my Gridfinity video, these parts still took 4 hours to print each. I had over 36 hours of just raw print time for this project. Sheesh. On the more fun side, I developed a new obsession while designing this project, one that allows for easy mounting of both the Pi and the UPS to the chassis, and that I could abuse for possible hinge ideas. Heat set inserts. This is a super simple concept, but it had intimidated me just enough in that it sounds like something I'll have to learn kind of way that I ignored it for too long. But anyone can do it. Just get a soldering iron or one of these basic kits you can buy online, take these metal threaded inserts, heat them up, push them into a hole in your part, 200C for PLA, wait for it to heat, saturate the insert with heat until it starts melting the plastic, gently push it into place, and release.
I absolutely abused these for this project. I used them to secure the Pi and battery in place. I used it to secure the keyboard. I used it for another part I haven't even revealed yet, and I used it for the hinges.
Oh. Hinges. I really struggled with this part of the build for so long. Since I wanted it to fold up and fit in a bag, I wanted a hinge, but I struggled to find any that would make sense for this kind of build. I had big shapes that were not even at all, and I wanted them to close up together, but still hold an open position when I write. Not an easy task. And again, 3D just breaks my brain. I wound up selecting these cheap brass hidden barrel hinges designed for small boxes and furniture. With some eyeballing on the placement, I determined that the gap between the barrels, when fully extended, would be enough to safely close the deck. Plus, since they were brass, I was pretty sure I could just pump heat into them and insert them into my prints like the heated nut inserts. In reality, I should have gone with the bigger sizes, but I proceeded naive and excited. As I plowed through prototypes, I ran into another problem. The parts were not sitting flush. Despite triple checking and redoing the process to be absolutely certain the cutouts I made were for the screen were centered with the shapes were the same size, and yada yada, somehow one print fit perfectly over the screen and the other just seemed offset from that one. I could never quite get them to line up. Originally, I thought this was because I was printing them on opposite sides, matching the flat ends to the build plate. So I flipped one part, added supports, and tried again, but ultimately I never got them to line up. I just could never get the sizing right for it either. It didn't make sense in my brain, but I'd put the two halves together, see that there was a big gap, measure that gap, remove that, just about that gap's worth in Tinkercad, and suddenly the print would be way too small, or somehow I'd still have a gap. Nothing I did would make these parts line up.
Worse yet, when testing the fitment, I made a grave error. Well, I really messed up. So, I've had half of the case on for a while, and I was experimenting with cable fits and cable runs, and I went to take the other half of the case that I was testing a print of off, and completely just didn't even think about the cable being in there and destroyed the USB port, because it just ripped right off and that is the power port. So it is completely smashed, and it's up against the standoff, so it didn't like go too far, but enough that the cable now rips completely off and the thing does not power properly anymore. Unfortunately, the cable is fine and the port is damaged. So I do have experience replacing mini USB, but not micro USB. I'm going to order, for the sake of time, because I really need to finish this project, I've ordered a replacement that should be the exact same screen, but I'm not tossing this. I'm going to keep it and replace the port at some point. I just am not sure how I will without having access to the bottom of the board, and it's like really stuck on there and I don't want to break the screen. So I know it's possible. I've done it before. Just not in time for this project. That feels really bad.
Eventually, I got close to what seemed like a perfect design, but man, that seam is obvious. My design had assumed the seam would not be super noticeable.
Once I had realized the two halves that I made were the best I was going to get, I designed a couple more parts. The first was a badge or a cover for the back. I wanted to make a sort of cyberpunk corporation style logo for the back to eat up the negative space. I wanted to use this as an opportunity to learn Shaper 3D on my iPad, but I kept running into issues getting duplicate shapes made and lined up, and gave up. Plus, the $300 per year subscription just isn't accessible for a hobbyist like myself at this point in time.
When I've been learning 3D thus far, I've learned making 3D with individual shapes. And this whole sketch model somehow just reverses everything I've tried to learn, and I really want to get good at this kind of stuff, but my brain just does backflips trying to understand it.
I made the design in Photoshop instead, converted it to SVG, and extruded that in Tinkercad on a big rectangle, and printed it off. Somehow, the corner on my first print got really messed up, so I had to print it again. I had similar corner adhesion issues on the second print, but was able to counteract it during the print, and it came out okay. I left 2 holes in the print to fit M3 screws in, and elected to drill holes in my 2 halves to use more heatset inserts. I cannot get enough of these. This time to attach the badge to the back and hold the 2 halves together. I wanted it to feel like this was some sort of old metal badge strapped to a machine, so the bolt heads showing through only added to the vibe. I also designed a faceplate to cover the bezel, the gap on one side, and the uneven alignment. This presented another challenge. The whole reason I had made this project in 2 halves in the first place was because it was too big to fit on my print bed. Thankfully, since the faceplate was slim, I was able to fit it diagonally across my print bed this time and sneak it on there, though I did have to spend a long time playing with brims and supports to get it to not turn into spaghetti.
I'm also used to designing things for 2D, for digital or a printed world, so while I enjoyed the process and was stoked with my design for the graphics on the bezel frame here, getting these teeny tiny, sometimes 1 millimeter or less in width pieces to actually print was not feasible. I might have gotten some, but the pieces kept popping off the bed. It was just never going to work.
Thankfully, I have another X and Y axis device that can make tiny things. My Cricut. I cut the shapes out of black vinyl, and most of them worked.
Lastly, I needed legs to attach the hinges to the keyboard. I elected for what is basically 2 rectangles and a triangle to slope the keyboard at an angle and give me a beefy post to put the hinge barrel in. Ironically, this was the simplest shape I had ever printed with this printer, and I had massive print failures. It wasn't an adhesion issue. I don't know what happened, but I think perhaps my nozzle was not perfectly installed, like exactly straight. I'd switched to the 0.2 millimeter nozzle for the badge and faceplate print, and then back to the 0.4 millimeter nozzle for this, so maybe it just wasn't installed perfectly. Eventually I got them printed with the holes for, you guessed it, heat set inserts. I told you I was addicted to these things. I abused them here, and they solved so many problems. But I had one final piece to design and print. You see, this battery bank is an odd one. To connect to the Pi's power input, you have to use a coupler that goes from USB-A on the battery to micro USB to the coupler, back to USB-A for a micro USB to A cable coming from the Pi's power plug to plug into it. Then you also connect a USB-C cable to the normal USB port on the Pi to avoid the low voltage warning and do the UPS side of things. So I designed a tiny, just little tiny box to house the coupler and help distract from the seam up top.
My favorite time had come, time to prime and paint. I wound up using a few colors of primer here, black as a base, and then some white and some teal in a sort of zenithal prime, a technique used in miniature painting to emphasize highlights and make speed painting easier. I wasn't going to be using speed paints on these parts, but I did want the option to weather them in certain places and have the contrasting colors underneath show through. So I actually went ahead and varnished over the primer blotches before painting. This way I could sand down the paint layer and reveal the protected undercoat, then varnish everything again. For the faceplate, I went with a bright color in my color scheme, and then used a combination of the black vinyl I cut on my Cricut and a black fine liner pen to recreate my design. I wish I had let this dry and hit it a few more times with the pen, as the design came out a little washed out, but I was in a hurry. I waited to varnish this until after the vinyl was applied and had set. That way the varnish helped keep the vinyl stuck to the frame permanently. For the badge, I hit it with some gold paint, then brought it to my mini painting setup to hit it with some silver and some black wash to give it that gritty old metal piece feel. Again, I wanted everything to have this worn industrial look, so I also hit everything with some sanding sticks to weather the corners. While I waited on paint to dry, it was time to set up the Pi. I had originally just imaged the latest Pi OS build, but apparently this specific Yaboom cooler I got requires special software to control the fan, RGB, and drive the OLED display, which makes sense, but none of those packages for it seemed to work on the newer builds. So instead, I had to use their image of Pi OS, and from there then tweak all of the scripts to account for the fact that I had changed my username from the default of Pi.
This is the thing about maker projects and tinkerer projects. You often get shoehorned into specific versions of software and other little things like that, and even then the stuff might not work. These things are more accessible than ever, but you'll have a way better time if you build up just a little bit of coding skills and troubleshooting skills for code along the way to fix things when they break. Even now, the fan works, but the auto-run script crashes after just a couple minutes, leaving the OLED screen to not update anymore. Frustrating, but I really don't feel like fighting with it at this point when the fan still seems to come on when it's needed. I don't know, I'll get to it at some point.
From there, I needed to set up my writing environment. There are a few word processing apps available on Linux that would suit my needs. OpenOffice and LibreOffice are a little too bulky for what I want. Focuswriter immediately goes full screen and is designed for, well, focus. But for me, the backgrounds are too cheesy and distracting. It's counterintuitive. For a WYSIWYG editor, AbiWord seems perfect, but it also seems to lag a lot for some reason. But I chose it to work with. I added its shortcut to automatically run at boot. You can full screen the program with F11, but there's no launch option for full screen. So I had to spend a good hour or two tinkering with the XDoTool program to send the F11 key after the program launched. It took a long time, but I did eventually figure it out. Now when I boot the Pi, after a minute or so, I'm presented with a full screen blank AbiWord document ready to write my thoughts. I also set up an alias command of dump that automatically mirrors my documents folder on the Pi to my NAS using rsync, so that I can quickly keep my writing in sync with my other computers and grab my scripts and manage my work without a lot of hassle. It was finally time to tackle the keyboard and the hinge. I disassembled the K3 wireless and lined up the hinge blocks and used metal drill bits to drill holes through the back of the keyboard and the metal shield plate.
Now, by this point, I was in quite the hurry to wrap this up. And every time I'm in a hurry with these projects, trying to finish them up before I run off to do my normal life stuff, I make mistakes. And oh boy, I made a mistake.
Well, I feel like I'm in a really tight spot now. I do this with every project. I get really good feelings from finishing stages of projects or finishing projects, and I don't always have like a whole day to dedicate to a whole project. And so when I start making really good progress on one, I want to rush to finish it that day because that would feel a lot better rather than keeping that creative feeling kind of bottled up inside of me, so to speak. And that leads to mistakes. I rushed this and messed up my hinge. When I was trying to press it in, I was actually putting more heat, dumping it into here, apparently, and pushing it in there a little bit. And I put so much heat because it wasn't going down that I just completely melted out this hole. Like, I can almost stick a finger in there. Way too big for my hinge now. And I don't know how I did this since I was making my template and everything. The spacing on these is not right. Now, in hindsight, now that I've had a little bit of time, I can see the obvious answer would have been to not build the keyboard yet at all, to attach them here first, and then figure out the whole spacing on the keyboard. But now I'm gonna have to pull all the keycaps out, separate the keyboard, and drill new holes that are kind of uncomfortably close to the originals. That's problem number one, is just moving them. It'll be tedious. That really sucked getting the keycaps off. Fixing the hinge, that'll be tedious, but easy. fixing the hinge, I'm not exactly sure what I should be doing. I could... So I'm in a couple minds. Like, I feel like at this point, I could make some sort of dowel that goes in the hole in the keyboard part and the screen part and just holds it there. That would finish the build. It would ruin portability. It would still give it that terminal-like cyberdeck look. Like, that would still work. But it wouldn't be portable anymore. I could try to make this hinge work, hopefully doing a better job on the second one, detach it from the keyboard first and blah, blah, blah. And just use a lot of super glue and baking powder, which I feel like I had in my shed here, and now I don't. Yes, I still have some. So baking powder and super glue kind of makes a bonded material, and just hope that it holds, which does in a way limit the portability, because if it doesn't hold, then it breaks as I move it. Or I look into some other hinge solution that I could put in place where these holes are, or attached to the back of the pieces to squeeze. I'm really upset. I have a couple days because I'm waiting on smaller screws for the Raspberry Pi. I really kind of wanted this done. Unfortunately, I think this is where I leave it for a couple days. I melted the plastic around that hinge piece as much as I could and sunk it in there. It's still going to be a massive hole that I'm going to try to fill with glue. But to make sure it stayed in there as the plastic dried, put a big battery on it. This one is in. It's not amazing. I will probably reinforce both sides with super glue too. But since I had it apart, I did need smaller screws. I was going to design this whole like butt piece to put underneath to keep the screws from scratching on surfaces and messing stuff up. But I have smaller screws coming. They're just not going to get here for 2 more days. So I think I leave this for tonight, call it a day. Tomorrow, I come back in, reinforce the hinges with glue and whatever I need, and then line up and drill my proper holes on the keyboard board. And then on Thursday, I'll be able to come in with the new screws, smaller screws, and finish up, hopefully. The only thing I'm actually gluing as part of the normal build will be this piece for the cable dongle, or the like coupler. Everything else, like the 2 halves, are going to be screwed together with this. So we'll see. I'm trying really hard not to feel just utterly defeated by this. I was on cloud 9 once I got the screen working. It was looking great. I know I can salvage this. It just feels really rough.
Eventually, I got it put back together. The only thing that seems to have gone wrong this time is around the question key mark not working. I think I either shorted it with the M3 bolt behind it or broke the resistor in the back, as I'm seeing since I've taken it apart again, but after stripping this keyboard down so many times, I'm just not interested in doing it again. One day I'll go back and cover it with capped on tape or something, or replace the resistor. We have a writer deck.
This thing is wonderful. Visually, it's exactly what I envisioned, or at least pretty close. The messy cable clutter only adds to the cyberpunk aesthetic, and the fan and OLED on the back add to that as well. The keyboard angle is perfect for how I like to write too. I've used it to write a few video scripts now, and it may not be the most immersive setup due to its small size, but it definitely helps me focus. I did miss pretty much all of my other design goals, however. It's not portable, the hinge is useless. Despite my many attempts at eyeballing it, the hinge will not close properly over the keyboard. The blocks just mash the F keys, and it doesn't fit flat. Effectively, it is a useless hinge. I am strongly considering just removing the hinges entirely and printing new legs for the keyboard that just have an angled post to keep the screen at a better static angle. That way I have it's more rugged and has better ergonomics, but I don't want to go through it all again right now. And otherwise, I mean, look at the thing. It's got a minimal footprint, maximal appearance, and perfect functionality. I flip it on. I would like a nice beefy power toggle switch next time, and then I write my thoughts or script idea or whatever, save it and sync, and pick it back up on the computer. Again, I have had issues with these WaveShare screens. The one I thought I broke is not broken, it still works. but the one that I bought brand new to replace the one that I thought I broke now just doesn't detect on the Pi. If I connect the Pi to another display, it works fine, and if I connect the Pi to the other WaveShare screen that I originally had for this project, it works fine. I've messed with the config files to add specific display modes for the screen. It worked fine for like a week and then just stopped working. So I'm gonna have to strip this thing apart again, including the keyboard, and swap screens now. But otherwise, when it works great. At some point, I'll rig up a hotkey to fire off the rsync command without me having to manually open up the terminal and type it in to make things even quicker. I also might have been experimenting with using word grinder in the terminal to write instead of AbiWord, as it's snappier and fits the vibe more. I have to use the Terminator terminal for that though, as the default one on Raspbian OS doesn't go full screen, but it's pretty neat. I've learned a lot of lessons here about designing and manufacturing something and like this, and having a little more patience. I also have a lot of things I would aim to do better next time. And trust me, there will absolutely be a next time. That's the cool thing about projects like this. The tools and the bulk materials or supplies that you acquire, the skills you build up, and the ideas you iterate on, all will allow you to keep improving your work and making more things. This is my first real cyberdeck. I've made other attempts at routing a computer through a bag and other ideas, but this is my first real deal. I have many ideas for others, and I definitely think I will continue to get better as I keep making things and designing or learning better design tools. I hope you stick around for future builds. Would you use a single purpose-built computer like this? Let me know in the comments below. Check this short to see what other Raspberry Pi projects you could use to enhance your space, and click the link in the description to learn more about my sponsor, ARM. Remember to be kind, rewind.